We spent a hideous amount of time in the last video optimizing this insert range method. I don't know why I got so stuck on this. I wanted to do this, but I learned a lot, and hopefully you learned a lot. We traded speed for memory. That's a typical sacrifice that we make. We sacrifice speed for memory, or we sacrifice memory for speed. We said toArray on new items, and that will obviously make an array and do a copy of the actual new items that come in that we're trying to insert. And we take that array, and now that we have the array, we can say .length on it just once. We saw that. And we can also use array.copy now that we have an array. And since we spent so much time making our insert range run quickly, I thought, I wonder how much slower my list is to Microsoft's, because Microsoft's list is used all around the world in many code bases, I'm sure, and I was curious how much slower is my insert range to their insert range. And so I wrote up a little test. I massaged the code we did in the last video. Remember, I say give me a range of, I believe it's 10 million items. Yep, 10 million integers. Make that into an array. Give me an instance of my list. Let's add 10 million items to it. Let's start up our timer. This restart simply resets the timer back to 0 and starts it all over again. And roughly towards the beginning of our list, in the 5th index out of 10 million, that's essentially the beginning of our list. Let's insert a bunch of items again. Stop and then tell me how long did it take to insert that range of items I told you to insert. And so this version of the code is an exact duplicate of this version. I copied and pasted because I was feeling a little bit lazy. I wanted to get the code all on the screen. And the only difference is this top portion is my list or me list, and this bottom portion is the built-in Microsoft list. You can see here in the output, when I output the number of seconds it took to do that insert, I report it's either me list or it's Microsoft's list. And I thought this was interesting. I thought surely Microsoft's would run faster than mine. And I Control F5 this, build this, run this, and you can see, oh, that's interesting. Me list took less time than Microsoft's list. I didn't expect that, to be honest. I didn't expect that. Must be a fluke thing. Let's run it again. Control F5. And, oh, look at that. I beat him by even more that time. Okay, well, let's Control F5. And come on, Microsoft. Oh, I'm not as smart as the developers at Microsoft. This doesn't make any sense. And so I went around and I poked around in Microsoft's code and kind of looked at their lists, their insert range on their list, and I noticed something. I noticed with an array, yes, Microsoft is, that's better time, but still Microsoft's a little bit slower. But Microsoft's comparable to me. It's comparable to my list with an array, but let's go to an IEnumerable. If I say IEnumerable of int, and I drop this toArray thing out here, and I just use the enumerable.range, which uses yield, I believe. Go look at my yield videos if you want to understand how this works. But it doesn't really matter because I'm using the exact same sequence for both my list and for both Microsoft's list. So the test is the same. It's the only thing that differs is, are we using my version of insert range or Microsoft's version of insert range? And so when we say enumerable.range, that no longer gives us an array. That gives us something using yield and blah, 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 blah. But now I can no longer say int array out here. I have to say IEnumerable of int, because range does not return an array the way I was getting an array before. I was saying toArray, but now we're forced to be stuck with just IEnumerables. All right, well, let's run this test again, and I suspect since Microsoft was a little bit slower than me with the array, they should be a little bit slower with this IEnumerable, pure IEnumerable. Control F5, build that, run that. You can see mine, me list took 0.15 seconds, and Microsoft's list, where is it? It's still running. Okay, I'm sorry to be so cocky here, but I was actually floored when I thought, I can't be as smart as people in Microsoft. It looks like I just might be. Look at me talk and talk and talk, and Microsoft still hasn't shown up to the party when I use this IEnumerable of int. Now it's early in the morning. I'm going to go take a break. I'm going to get some cereal and eat a little bit of cereal. I'm going to see, does Microsoft ever show up to the party? Well, we'll find out. So I just went and got a bowl of cereal, and you can see Microsoft still hasn't shown up. They still haven't shown up to party. Yeah, I'm still waiting for them to see if they'll make an arrival. Now, this may be a an unfair test test of 10 million items. I mean, how often do you deal with 10 million ints? But I thought it was interesting that they're not here yet. Of course, I'm kind of picking on one developer. Probably one developer at Microsoft wrote their algorithm, and the developer probably doesn't even work there anymore because their list was written, oh, dare I say, about a decade ago. So it's probably fair to say that their developers no longer there. Probably for good reason, actually. All right, let's see if they ever show up. Well, I'm done with my breakfast, and Microsoft still hasn't shown up. So, I yeah. I was really expecting them to be done by now, but I guess not. So let's shut this down, and maybe I don't know. Let's reduce it down to 1,000,000 items. Let's see if Microsoft shows up to the party for 1,000,000 items. You can see here's me list. Obviously, mine's done sooner. Microsoft still always. All right. Well, let's do less than let's do 100,000. All right. Control F5, and you can see me list. And, oh, there we go. There we go. So 100,000 items. My version took 0.00178217. How about 0.002 seconds, and Microsoft's took about 4 seconds. Huh. Now, maybe the developers at Microsoft made a conscious decision not to trade memory for speed. Remember, my version traded memory for speed, whereas Microsoft, they traded memory for speed. Now let me show you something else here. In insert range here, instead of inserting a bunch of items, let's insert my party ages. Down here, we'll insert my party ages too. Now remember, when I instantiate these lists, I initially say, hey, add a bunch of items. Okay, so essentially, inserting my party ages should be the same as inserting a bunch of items. Same thing down here with my party ages too. Let's compare Microsoft's version to my version and see if they do any better than that. Oh, look at that! Look at that! Microsoft smoked me. Okay, their list was way faster than mine. In fact, I'm tempted. Let's bump this back up to 1,000,000. You can see, yep, Microsoft's still smoking me. Let's do 10 million. Run it. And Microsoft's still smoking me. So when I insert the exact same instance into itself, okay, I'm inserting my instance into itself, Microsoft's smoking me. They're smoking me hard. Okay, but how often does that happen, that we're inserting a list into itself? That's kind of I don't think I've ever done that, to be honest. Well, I just did it, I guess, in this video. And then let me show you one more scenario where up here I'm actually going to change this to a list, and then enumerable.range. I can actually, just like I did with toArray, I can say toList. So now I'm going to say a bunch of items down here. I'm going to insert a list into me list. That's kind of interesting. And then down here I'll say a bunch of items as well. I'm inserting another instance of a list into the built-in list. Let's see if Microsoft does any better than I do. And it looks like they barely do better than I do. That's kind of interesting. So what's going on here? Because when we did just the IEnumerable thing up here, Microsoft didn't have a prayer. Okay, where I insert a list instance into a list, Microsoft is comparable to my approach for sure. And then when I actually insert the actual instance into itself, how often you do that, I don't know, but when you actually insert the actual instance into itself, Microsoft just smokes me. I don't even have a prayer. Let's use the .NET Reflector and look at Microsoft's insert range code and see if we can figure out what they're doing that we're not doing. Maybe we can figure out why, when I just use IEnumerable, Microsoft stinks. But when I do use these other combinations, Microsoft is either comparable or they're smoking me. 1 second while I pull up the .NET Reflector. Okay, I have here Microsoft's Insert Range method open in the .NET Reflector. This is a very handy tool. I tell you, go buy it. It's awesome. Go look at other people's code because you learn a lot, just like we're going to learn right now. So let's say they say, hey, if you're trying to insert something that's null, forget it, I'll throw an exception at you. If you're trying to insert at a position you shouldn't be throwing or shouldn't be inserting into, I'll throw at you as well. We forgot to do this boundary check. We really should have. And then, oh, look what they do. They do this iCollection. I haven't told you about iCollection, but it's just an interface, much like IEnumerable, but there's more methods you can call in it. And they say, hey, let's see if we can cast collection to an iCollection. Because if collection implements iCollection, we can take advantage of some things. Notice they check here and say, hey, if the cast worked, figure out how many items are in there. And if there's more than 0 items, resize, insert capacity, I believe that's what I called my method to size ourselves to size plus count. And then right here they say, hey, if the index is less than my size, we need to shuffle some people down. This is their shuffle right here. And then look at this. Here's the optimizations. They say, hey, if they're trying to insert into ourselves, that they passed this instance of the list into itself. That's what this is checking. If this is equal to IS2 being a reference to the exact same collection that was passed in here into insert range, and this compares references, right? If this is equal to IS2, then simply use array.copy and directly access items inside of myself. I know that I'm inserting inside myself, so items is the underlying array that we're trying to insert. So simply do the copy. They essentially do exactly what my code does, but they don't make that second array. In my code, I made that second array, but they're smarter and say, hey, we can access ourselves. We already have access to ourselves. Go grab those items and copy them directly where they need to go, and we're done. And so these 2 lines of code, this is why Microsoft is smoking me so well. These 2 lines right here is because the developer at Microsoft was actually pretty smart. They say, hey, if you're going to insert into yourself, you got access to the underlying array. Just shuffle the items around, and we're good to go. Else, we know it's an iCollection, so we can say, hey, oh, look, the developer traded memory for some speed here. They said, let's make an array, and then let's use the copy2 method. Copy2 is a method on iCollection, and the developer knows at this point they have a reference to an iCollection. That's what IS2 is. It's a reference to an iCollection. So give me some memory, copy to that memory, and then take that array and copy it to our underlying array. It makes you wonder, you know what, could they have gone without this and just forget all that and say, hey, let's use the iCollection copy2. That'd be a good exercise you could try, actually. Could they have used the iCollection copy2, just like they're doing here, but instead of copying to some temporary array, could they have just directly copied to items? I believe they could have. So this is actually sloppy, if I'm correct. But I could be wrong there. And then they obviously increased the count. Now, let me show you why Microsoft's implementation was so hideously much slower than mine when I just did the IEnumerable thing. They say, hey, you know, if we can't cast to a collection right here, if this if fails, then we're going to end up at this else. And let's look at what they do in that else. Let me scroll down here. And it says, oh, what are we looking at here? This is essentially a for each. It's a clunky for each. They just say, let's just move next, put it in there, move next, put it in there. But while they're putting it in there, they're using insert. They're inserting each item one at a time. And you know, just as well as I know, that when you insert one at a time, that's going to cause the list to resize itself over and over and over again. So I'm actually highly disappointed in this approach here. And it's funny because it's like the developer was almost kind of smart and said, let's make an array, then we'll copy that array over here. But couldn't we just forgone this temporary array? If they were going to make an array, they should have done what we did in our code, made the array here, and then did the copy to right there, and saved a lot of time. Imagine how many places, now I don't know across the world how many places insert range is called, but I'm willing to bet it's more often than not, and that's all around the world, and yawn. Here's some code that's going to make your code run slow, and it could run. I'm getting very opinionated here, and I'm being very unfair to whatever developer wrote this, because there's plenty of times I write crummy code. If you watch any of my videos, chances are you see me write crummy code all the time. So it's not fair for me to be so unfair, but I am actually surprisingly disappointed with this one. Let me get off my soapbox and let's continue and move on and learn something new.